string here. Read the question. No? How come this is fixed axis rotation? I think that things are different, you know. After some time, it's rod having both the translatory rotating motion. I think I'm showing here. You should look at this. Both having translatory rotating motion. What about here? Only rotating motion. Both translatory rotating, only rotating motion. Okay, no. So here also the same thing. Just after string cut, the rod will have both translatory, rotatory, then afterwards only rotating motion. So what is our question? Just after right string is cut. So I think in the numericals, you are supposed to make observation of this condition. Again, we are going to proceed with the same method. So initially, this is the weight mg, center of mass. So there's a tension, T naught and T naught electric with that one. Then the moment I cut the string, so what will happen? The weight mg will act. Then because of the weight acting, what happened? The rod wants to move vertically down. Then what happened? The tension, what happened from T naught will take some other value. So let it be, say T. Then the center of mass will accelerate. So at that instant, translative motion. Okay, now try to see that what are all forces are acting on the rod. Along y-axis, mg minus t sine theta. So there'll be acceleration of center of mass along y-axis. There'll be acceleration of center of mass along y-axis. T constant is also acting. So there'll be acceleration of center of mass along x-axis. And about what point the rod will rotate? The rod will rotate about center of mass only. And this is alpha c. Not about point P. Any reason for that? The string will be taut and inextensible. Write all the possible equation. So let's write one by one. For translative motion, mg minus t sine theta equal to mscy. T cos theta equal to m into acx. Acceleration of center of mass along x, along y. So this is about the translative motion related to this. What about the rotating motion, t sine theta? You resolve this. So what is the length of the rod? This is L by 2. So how much of torque here? T sine theta is the tension that will act perpendicular to the length PC. So T sine theta L by 2. I'll write down so you can measure this. Cp is equal to moment of inertia IC alpha c. What is Cp? Cp is equal to L by 2. How many unknowns are there? 4 unknowns, no? ACY, ACX, alpha c, and tension. But how many set of equations we have? 3 equations. 3 equations. What we have? I need one more, and I'll go for constraint equation. As the string is inextensible, so therefore the acceleration of point P of the rod along the string must be equal to 0. I think that's the only thing which is going to help us now. And what is the tangential acceleration of point P? L by 2 alpha c will be vertically down ACY and ACX. So I'm going to resolve all. So I'll show it. So let me take this one. So this is the point. So there's a string here. So what are the accelerations? So one, no, ACY will be like this. And L by 2 alpha, tangential acceleration will be like this. And this is a point P. And this is theta. This is theta. So this should be the theta. Try to look at all the things. L by 2 alpha C. So there's a string. What should be the acceleration of point P along the string? Along the string, it should be 0. Any reason for that? Because the point P, what happened, will be connected to some P dash. So what should be the acceleration of point P and P dash along the string? It should be equal. Constraint equation. Because the string should be inextensible. This is a test. Acceleration of point P dash must be 0 connected to string. So what should be the acceleration of point P along the string? Must be 0 because for the string to remain inextensible. So let's write that equation. Acceleration of point P along the string. Now resolve all this. So this will be ACX cos theta L by 2 alpha C sine theta minus ACY sine theta equal to 0. So 4 equations, 4 unknown. Solving will get the required answer.
So isn't it plus L by 2 alpha C sine theta?
This is positive. Okay, thank you, thank you. Yeah. Okay, fine. You see that just general idea. This what we did for rod. So earlier the string was vertical. So string can be oriented in any way now. There's a beginning. So there's a beginning. Slowly what happened? We'll explore the higher level problems. Now the sir rod will it be later on in the end? I'll conclude. So just after string is after some time what will happen? The rod where the rod will be. You must have this very important. So don't write equation. Generally, what will happen? Tell me. After some time, what happened? Say because of ACX, what happened? The point P will move, no? Will move horizontal. The point P, how the motion of point P will be. They may ask you in exam like this. After cutting the string, how the point P will move. So students, they try to write mathematical equation. I think there's a highly stupidity here. Very generalized idea. So how the rod will try to swing like this. And the point P, what happened, will move up. If it moves up, string will become loose. So there's ruled out. Can it move like this? If it moves like this, and the rod what happen, will swing. So is it possible? Can it move like this? Not possible, no? Because of acceleration of center of mass. So therefore it should move. And also ACY is there. So because of ACX and ACY, how the center of mass will move? We'll try to move like this. We'll try to move. Then how the point P should move? We'll try to move like this. So the acceleration of point P and C after some time need not be in same direction. So they will both will move in fourth quadrant. Finding very difficult, you take rod, just hold like this, release it, no, and make observation of this. Nowadays we have mobile. Some of you are having very good mobile. Slow motion is there. So take that video in slow motion. Do make observation. Put some sticker here, red color. Do put something and make observation. What's wrong in analyzing like that way? So you'll get exact picture. In exams, instead of asking numerical, if I said paper, I'll not ask that because everyone knows you'll get answer. I'll just ask you, just after string is cut, center of mass will move. How it will move? It will move in a fourth quadrant here. So if I take quadrant, after some time, our center of mass will be moving in fourth quadrant. What about P? P will be moving in fourth quadrant. Will try to move somewhere like this in a plane, not only horizontal or vertical. Because you do one thing, just make string vertical. When you make string vertical, I think point P will come somewhere here, no? Well, I'll give a rough diagram. Please at least do understand what is the biggest problem you are going to face? This what happens no after some time. So the point P was at horizontal. You look at this position. It was here. So when the string becomes vertical, so point P will not be here. Will be somewhere here. I'll take it out again. You'll get confused. So in exams can be asked questions for you. You should know how that motion in general takes place. Now, why only rod?